Suppose we start off with a sum of money, X, which we'll call the initial amount. We invest X, and after a period of time, we have the sum Y, which we'll call the accumulated amount. The amount by which X has increased is Y minus X, which we will call the interest earned on X. We tend to be concerned with the rate of interest. In terms of X and Y, this is given by rate of X of Y. By definition, rate of X of Y equals Y minus X divided by X. In practice, we already have the rate of interest, and given the initial amount, we wish to calculate the accumulated amount. So observe, rate of X of Y equals Y minus X over X. If we shunt the this to the left-hand side, we will get rate of X of Y multiplied by X equals Y minus X. We shunt again. This time we're shunting the negative minus X over to the left-hand side. We arrive at rate of X of Y times X plus X equals Y. Now, if we factor the left-hand side, because both, you see we've got X here and we've got X here, so if we factor out that X, we get rate of X of Y plus 1 Y plus 1 times X equals Y. Now, we will call the expression rate of X of Y plus 1 factor of X of Y. And so, our final expression will be factor of X of Y times X equals Y. Factor of X of Y we'll call the interest factor. In some places, this is called the accumulation factor. Now, we've seen that after one period of time, the accumulated amount will be X multiplied by factor of X of Y. Now, after 2 periods of time, it will be X times, this is assuming compound interest, of course, it will be X multiplied by factor of X of Y multiplied again by factor of X of Y, which is the same as X multiplied by factor of X of Y all squared. Now we can see the pattern. For n periods of time, it will be X times factor of X of Y to the power of n. Now, let's suppose we have the interest factor, FAC. I'll let do be the number of time periods. Then, the accumulated amount we can express using the function reap. Reap of FAC of do X, which is equal to X times FAC to the power of do. Let's look at an example. £100 is deposited into a savings account. What is the accumulated amount of the account after 5 years, assuming that compound interest is paid at the rate of 4% per annum? Well, we're being asked to calculate reap of FAC of 100. This is the expression we have to calculate. Now, what is FAC? Well, remember that the FAC is equal to the factor of X of Y, which is equal to the rate of X of Y plus 1. Now we are given the interest rate of interest is 0.04. Hence, FAC will be 1 plus 0.04, which is 1.04. So, we have to calculate reap of 1.04 of 100. Now, remembering that the definition for reap reap of fac of duo x equals x times fac to the duo. So in this case, x is 100, so it'll be 100 multiplied by fac is 1.04 and duo is 5, so it's 100 multiplied by 1.04 to the power of 5, which is roughly 121.66. So after 5 years, assuming of course we don't take any money out, depositing £100 at the rate of 4% compound interest per year will give us £121.66. Now, here we did this by hand, but I just want to show you before I go how we could use the language Haskell to implement a reap function. If I just come into here, now what we'll do is we'll say let reap factor x equals x times, star is multiplication, fac star, this double star is exponentiation, duo. Yeah, okay. And now let's do our example again. Our example, remember, was reap. We had the interest factor was 1.04, the duration was 5, and the initial amount was 100. And we get 121.66. So that's quite nice. Next time we'll delve a bit more into interest. In particular, we'll look at what effective interest is. Until then, goodbye and God bless.